problems is the atmospheric effects and the space errors, especially the scintillation when signal reaches from satellites to Earth station, because they are 24,000 miles away and they are basically surrounding the Earth. The second thing is the system errors, which we are calculating the clock errors, because satellites are in atomic clocks and we are in the normal clock. The third one is environmental errors, which is the multi-path, when the signal is received by reflected or reflected path, and the urban areas where the signal is lost. Okay. The navigation in urban area is main problem, because you don't have all the satellites available at all the times. And these are some experiments. This is Sakhar IBS different buildings where we conducted, and we divided the environment and developed that type of solution for that particular type of environment: open sky environment, partially covered environment, and fully covered environment. And here is the detail of signals, which I am happy to discuss after my presentation with anybody who is interested to carry on this research. The characteristics of satellite signals. These are some dynamic experiments. We put the receiver on top of the car and then we navigated in different speed of circle, and then we calculated how much is the signal loss and which particular algorithm is used for that solution. And these are some signal details, which I am not going into the details. Some key findings is that availability of GNSS and position, navigation and timing services is great influence by surroundings or operating environment, especially in urban areas the signal is lost. So that's why we apply adaptive navigation system. It's basically a machine learning algorithm. There are a variety of machine learning algorithms which we are using. 5G and 6G for precise navigation. Your mobile is having nowadays 4G, and then 5G and then 6G. What are the supports where your signal is not lost? You can easily, like here you come, your signal is not you know, many times you are basically losing your Wi-Fi, so you cannot go to the internet. So 5G and 6G will provide you the best navigation and the access to mobile technology that is seamless. Okay, and these are some features of 5G and 6G which we will discuss in detail very quickly if you go through this video, which is a couple of minutes. Can you respond? This is the visual navigation system where we have the GPS and then supported by visual environment. So here is the mobile phone. Can you raise the volume?
For an appointment or a tech company conference that happens, and then your phone says head south on Market Street. So what do you? Pay for an appointment or a tech company conference that happens. For an appointment or a tech company conference that happens, and then your phone says head south on Market Street. So what do? One problem, you have no idea which way is south. So you look down at the phone, you're looking at that blue dot on the map, and you're starting to walk to see if it's moving in the same direction. If it's not, you're turning around. They've all been there. So we asked ourselves, well, what if the camera can help us here? Our teams have been working really hard to combine the power of the camera, the computer vision, with Street View and maps to reimagine walking navigation. So here's how it could look like in Google Maps. Let's take a look. You open the camera. You instantly know where you are. No futzing with the phone.
And cameras to navigate the roads and levels of automation. Today, your car is at level 1 with features like cruise control and parking sensors. But by level 5, the car can drive itself completely. All you do is tell it where to go. But what does that actually mean? Well, with computers at the wheel, you'll get from A to B faster, with less congestion and less pollution. Once you arrive, the car will even park itself. But their biggest benefit is safety. Every year, more than 1 million people are killed in car accidents worldwide, and 90% of them are caused by human error. Sometimes we get tired, we lose concentration, and every now and then just get it wrong. Could driverless cars be safer? We'll have to be able to make quick decisions in all kinds of situations and share the roads with conventional vehicles, pedestrians, and cyclists.
So, algorithm models, you can use anyone depending on which type of application you are running. Basically, supervised and unsupervised. I'll go to the mathematical models, maybe later on with any researcher who is more interested in that. Here, we have also published two papers which I am happy to share with the interested researchers. The main method, this is also a K-nearest neighbor method, which we are working with one of my PhD students. She is working on that. Another one is learning simple decision rules, how to train a model and then apply that particular model. The classification models is one which we are using. We can also discuss that. That model is basically the reinforced model, which I will discuss with you later on of the global navigation satellite system. The main purpose is basically to combine it with the indoor navigation system, so you will provide seamless guidance. The main challenges for machine learning, here the challenges are also given and include my presentation. It's basically, it can help you to anticipate what type of phenomenon you will be facing and how to initiate the optimal mitigation. Mitigation means overcoming that error, which is basically disturbing the accuracy. The future perspectives, the usage of machine learning and sensor fusion to improve the accuracy, like sensor means your electronic compass and other things, and that gadget will basically guide anybody or any car or any vehicle to go to its required destination. I tried myself best to be in time, but again. So thank you, sir. Any question? Anybody?
We'll have the question answer session after the.
That's fine. Yes, ma'am. Thank you very much for your time for listening. Thank you.
Okay. Since we keep the questions until the end of the session, so we go to the next speaker, Professor Dr. Muhammad Abid TI from Comsats University Wang Campus, with title of the keynote, Need of Computer-Aided Engineering for Real-World Engineering Problems. So with this,
I'm already here, so say 1 minute.
Okay.
First of all, thank you very much for giving us the opportunities to the researchers and giving us a chance for winding up with the researchers to review. My talk is very important. If you see the need of computer-aided engineering for real-world engineering problems. You see, when we, two decades before, there was a problem, but still we feel in Pakistan, we have a limited focus for real-world industry solutions, especially when we talk about the Pakistani industry. And we have limited interaction between academia and industry. We all know. We keep saying, make a gap, but still we are not being able to cope with that. We also have a limited interaction between academic discipline even. We talk about this is the beautiful conference and a multidisciplinary. So we always work over the wall, of course, but we have to work together if we want to give a solution. And the teaching we do with the limited practical applications. Even our mentor, the teachers are not trained for the practical applications. And we have limited experimental test facilities for research in academia. We all know that what we have in the universities and what we'll be needing in the future as well. So present practices are generally based on the limited and simplified data and empirical models. So it means we have lots of professionals, we don't have those experts, although we are talking about this technical university. So we have to have the competent professionals to look into the real world solutions. So we have this scarcity of resources to bring about the needed revolution in the industry. What industry needs, we have to talk to the customer, the end user, what is required. So what we feel, system is still observed inadequate to address the 21st century industry design challenges. So with that preamble, I will show you some of the critical problems which we have solved, which we started sometime before, and we have addressed these issues, and we can do that in academia. And this is not only for engineering, but it's also related to technology, because the solution comes from, if we talk about the STS, Science, Technology and Society, the solution can be a full package in terms of working together. In the defense sector, the biggest sector is your process industry. When you talk about the petrochemical industry, oil and gas sector, or nuclear industry, even from the domestic problem, we have pipings and everything. And if you talk about the marine industry, you have ships which have miles and miles of pipelines. And if you talk about aerospace, we have different boundary conditions in terms of high temperature, high pressure, and low temperature and low pressure. So if you see, these structures are really critical. When you are going to test these, experimentally you cannot test that. We work with the oil and gas sector, where we have the flanges of sizes of half inch to 36 inch diameter. And then we have classes from 150 to 2500 size of classes. And then we have carbon steel and stainless steel, high temperature. So it's really impossible to test even one size of this 4 inch size of the flange. And the major problem with the industry is the knee grades. And we are not talking about hypothetically. We have to work with the codes and standards like ASME, British, European codes and all those codes. And we have to make the knee grade. What is the impact on the environment? So we work with the real, and you see, if I go back to my slide, if you can see that, you can see all these geometries are non-linear. The boundary conditions are non-linear. So it's a really critical, when you talk about the big data, so data has to be there to have the right solution. The only solution is you have to work with the computer engineering, the modeling and simulation. Use ANSYS or any of the tools for the numerical simulation, and it's not easy. The major solution we provided was the board technique procedure for half inch to 36 inch diameter. So when you talk about the big diameter, it's very difficult to talk with the tight the top edges. You have to have the strut tensioners to tight it. Even your pipeline in the marine industry or in many of the industries, you have the combined boundary condition when you have tons of water on your pipelines. And you have a very high temperature for the exploration from the North Sea, and when it comes to the ground, it's a different temperature. See, in real world problem, the static boundary conditions are not there. There are always dynamic boundary conditions, which is a real world problem. If you see this, we also work on with the welding procedures. We are not talking about the one problem, it's a huge industrial codes and standards which were actually been formulated based on the parameters. If you see, if I cannot go into the details, you can see the different parametric studies on your left hand side where the effect of the welding speeds and the sizes and all that is there. So it's a very big data, and multi-pass welding has to be done. Practically it's not possible, but simulation, yes, we can do that. And we have done that, and we have given these standards to the Pakistan Welding Institute and the Welding Institute and all these welding institutions which are acting as the codes and standard into the industry. I will skip some of the slides related to that. Again, the other thing is why, when we talk about the energy conservation, if you can control your heat source model, then you definitely can control the deformations. It's a very critical problem, because if you weld a pipe with a flange, not with a pipe with a pipe, because it's a different geometry, then we have to think about how much initial deformation is there so that we can ensure there is no leakage from the joint. And again, this is a huge parametric study, so there is big data involved. So we have used our own algorithms to weld these. And these algorithms are being patented by the industry. This is one of the very critical problems when we talk about the energy efficient building. This is a poultry shed, which is an environment control poultry shed. We work with the K&Ns, menus. This is just a single story. 300 feet long, but if you have a multi-story, so they have a different bonding conditions. And it's a very interesting problem when we have a chicken from the one day, and then it keeps on going, and it becomes 21 days or more than 21 days, and you see the bonding conditions keep changing. And no human interaction with the bird, so it's fully automated system. So we have to simulate that. I can show you some of the simulations where we have to distribute another 300 feet or 500 feet long tunnel where we have the temperature which should be uniform. So what should be the bonding conditions to apply? So this is only possible with the simulation. Practically it's not. Even the sensors are there, you cannot do that experimentally. The other critical problem like this one, which is a critical structure like the heavy capacity cranes. So the girder is a box girder which is a totally non-uniform geometry, if you can see, in order to avoid from the torsion and keep it in bending. So we provide them even the welding procedure, the cutting plane, so that you don't waste your plates and to save the materials. So again, a software has been developed, given to the industry, and they are using it for the proper planning procedures. If you see, this is a really mega problem. We worked on the Turbella Dam where we have a lot of sedimentation issues, and it's miles and miles of reservoir. How you can model that? So we use computational fluid dynamics, and this is a really serious issue nowadays, not for the Turbella Dam, but for Mangla and other reservoir. All of barrages are full of sediments. You are sitting on the barrage of you have in your own city. So this was a real issue when these heavy floods were there. So we model that, and each tunnel, it's not a pipe, each tunnel is a 30 feet diameter, it's a big tunnel. So how you simulate it, how the sediments going, how they are damaging actually the turbine. So you can see the big swirl is over there. So you cannot do it experimentally, not possible. Only simulation can tell that, and we did it. And you see how the sediments are moving forward, so that it's a phenomena. If you can see this black and white, these are the Turbella Dam was made. There was no sedimentation now, but in 2017, November 2023, it's full of sediment. So it's a big threat to the dam to be choked if any other event comes up. See this one. And we model that, run it for maybe 10 days of simulation, and that gives you how the sediments are moving forward when this condition becomes critical. So these are the tunnels in the Turbella Dam, where each tunnel is 1 kilometer long tunnels, and the diameter is more than 30 feet diameter. So it's a big challenge to measure to predict the life of these tunnels, and we have done that with the fluid structure interaction and all these parameters. It's a huge data available, which have been we have developed our own algorithms. You see, we talk about the renewable energy systems. If we can talk about the micro hydro projects, maybe wind turbines, and maybe we have also written papers on that. You can actually optimize your wind farms with these data. You know the wind farms are really a big farm where we have the multi-stage structure there. But this is this was a very critical problem. We must Pakistan railways. Some time ago, Chinese bogies were purchased, and there was some problems. So there was some fatigue, and the tracks were developed, and we optimized this and give the solution to them, and this is not safe. This is again biomedical applications. We provide the full solution, manufacturing solution, full business plan, so that these are cheap and can be manufactured in Pakistan through these simulations. The most critical problem nowadays is the spine. It's a one column where we all will survive. So from cervical to the back. So the objective is to model your one of the spine vertebra in the real time by the CT scans and manufacture it from the 3D printing and replace it with the surgery in the real time. So we are very successful alhamdulillah. We have and the data should be 100% accurate for all of your spine, each vertebra. So this has been done. Or we are working with the hospitals in Pakistan at the moment. This is another high-end problem where we are actually manufacturing this thickness of maybe 1 inch to 2 inch, where actually if you fire a bullet, it does not pass through that. So this is for the lightweight, high-impact structure problem for the defense industry, and we are also working for the commercial applications. This is, you see, this is a 3D printed structure where we have sheet memory alloys and the other materials. That's a very complicated problem. If you can see, I can show you on the next slide some simulation. So the bullet fired at 100 meter per second and 200 meter per second doesn't pass in. All this energy of thought in that structure. So the other problem which this is we talk about we are very much interested and we are working on. Let me share with you. I am also working as the chairholder for UNESCO chair for knowledge systems on integrated resource management in concept for campus. So we are mainly the surface and groundwater modeling in the drought and the flood protection, and we have recently in the flood area we are working on that. So all these predictions have been done, and these are submitted to the government, to the Ministry of Climate Change, so that mitigate these solutions. Finally, my final slide. I'm from Conference University, which has 7 campuses. We have more than 1,200 PhD faculty, and we have multi-disciplinary more than 10 programs. So we offer you to join hands with us. We is a really multidisciplinary institute, and it's an opportunity for all of the colleagues, not on the national level, rather on the international level. Most of the projects are working with the international community. I'm very happy. Vice Chancellor sitting here, he is also in the center. So we'll be here to do an MOU to work together in more what we have done. These are the buzzwords not for the Pakistan, but for the whole community. So, if I summarize this last slide, what's needed for Pakistan? To establish a strong presence of computer-aided engineering design practices in Pakistan due to limited experimental base. So, lack of outreach. So, again, the thing is, no matter it's a technical university or engineering university, we have to outreach to the industry. Our industry has to outreach to us for their solutions. And these all case studies shown you is done indigenously in Pakistan, by our own students, by our own faculty. So we have that capability with the confidence that we can do it. And my last sentence always is, academia has to take lead, industry will follow it. Thank you very much.
Thank you. Mohammed Abid from Concept. And I think it will be an excellent suggestion that came that there should be more collaboration with Concept between, I think, the Technical University, Jaipur, Marsa. They also have this, and we had 2 very elaborate presentations. I personally think that there should have been a separate session for each of these. So we have actually too many speakers, unfortunately, too many subjects to cover. So I will now request our next speaker, Professor Dr. Sayyid Haider Abbas Musli, who is from this very institution, the Mehran University Jaipur campus. And again, I'll request him to be very brief. And I would also, in fact, his presentation is on integrated AI. So it's good to see that. In fact, I will request all the speakers later and audience to actually look at what is the impact of the recent developments in the artificial intelligence. Because I think the artificial intelligence may disrupt all the professions. You know, all the, I know they've already, I understand the artificial intelligence, this ChatGPT has passed the doctor's exams, it has passed the lawyer's exams. Luckily, I just saw a post this morning that it has not passed the accountant's exams. So at least I'm safe so far. So with that, please, thank you.
Thank you very much. My topic of talk is regarding the healthcare specialists who can use the artificial intelligence. Before starting, I have always an objectionable note on the word artificial intelligence. Nowadays, it is much more than artificial, but it's more than real factor-based or real aspect-based intelligence. So it is now not become an artificial. So now the topic of the research is towards integrating AI and Green Internet of Things in healthcare for achieving United Nations Sustainable Development Goals. So you see here that this is an integration of the AI with the new terms used as green IoT. Before that we had IoT, Internet of Things. But now due to the climatic changes, the term has developed as green IoT, in which the wearable sensors, the 4G, 5G and the latest 6G technology will play its role for the development of the humanity, especially for coping with the much demanded our healthcare system. So you will see here that with the help of the AI algorithms and with the help of AI techniques and with the help of computerized systems, we can integrate the healthcare system with an AI-based system to facilitate the stakeholders like the practitioners, the doctors, and the patients, and the healthcare hospitals. So this is also the goal of the United Nations, because by 2030, United Nations have developed the goal. You know all, most of you know all that Sustainable Development Goals of the UN, and this is matching for the UN goal number 3, UN goal number 4, 9. It is good health, it is education, it is the IT. So first of all, it is about the examples of the IoT or green IoT, like energy efficient IoT devices. Before that, we lacked the energy efficiency, and now there is a research going on upon the energy efficiency. It means the efficient technologies and devices which can be utilized in IoT. And then we have smart grid and renewable energy, then sustainable materials, environmental monitoring systems and manufacturing process, and smart cities equipped with the computational engineering. This is very much new innovation, that is the computational engineering, and it is being embedded in the latest development of the cities and become as the smart cities. And then this agriculture. So this is also an IoT, green IoT agriculture system that is being developed. Now we say that how the green IoT can be combined and give fruits to the community for the health system or smart health system. In this, we have 4 to 5, 6. One is the predictive maintenance of medical devices. Next is wearable devices. The third one is the remote patient monitoring. And the fourth one is clinical decision support systems. So these are actually the 4 systems which can be integrated to give a smart IoT, green IoT based healthcare system. And we know that an AI-based healthcare modeling involves use of AI algorithms and models. And these models, as Dr. MadaD Ali has already explained, that these models can be utilized in satellite technology, but these algorithms like the deep learning algorithms. So the deep learning algorithms is very much an impressive type of the algorithm that can be used for MRI systems and scanners, and also we have AI-based healthcare models that can be done by use of predictive modeling. And then, what is the best healthcare system nowadays? It is extendable artificial intelligence 5.0. Before that, we have the artificial intelligence healthcare based systems. Those were limited up to the healthcare system 4.0. But now it is the age of the 5.0. Now this 5.0 healthcare system is based on AI integrated with smart wearable devices and also the predictive modelings as well as the decision support system. So XAI, it is the extendable artificial intelligence, is especially relevant for applications such as clinical decision support and so on. And then this is a model that is basically shows the relationship or connectivity of the AI models with the healthcare system. So the healthcare 5.0 is nowadays a much more developed and trumpeted technology based on the 6G, sixth generation telecommunication systems and universal mobile telecommunication systems. So 6G technology, 6G networks, it is the trend and the technology that is coming in, and it can be utilized in healthcare system. And in this you see the different algorithms results are produced, that is the deep explanation, interoperable models, and model reduction. So AI models and the algorithms used in healthcare systems are CNN, the deep learning, then the RNN, recurrent neural networks. Like I say, the convolutional neural networks can be used in X-rays and the CT scan machines, and also the RNN, that type of deep learning algorithms can be useful for analyzing series of the data such as fashion, vital signs like blood pressure, temperature, pulse rate, these types of the things, heartbeat and so on. And then it is SVMs, that is support vector machines, types of machine learning algorithms, and these can be classified in various healthcare classifications. So the FVMs are often used for disease diagnosis and predictive patient outcomes. So predictive patient outcomes is a predictive technology that before a person or before a patient can be engulfed into any disease, it can be realized through the AI algorithms, and it can be predicted. And then decision tree is a popular algorithm that is used for best treatment option for a particular patient. So there are a lot of the options that can be given to the patients, but which one is the best one? So the AI model and decision trees can give us that solution. And then random forest is also in healthcare. The forest often used for disease diagnosis or predicting patient management. And when we talk of the 6G healthcare system, it requires ultra-fast data transfer speeds. Now, ultra-fast means almost 200 Mbps communication channels. And we have, the system should have low latency. It means the delay must be at a very minimal stage. So, we call it a low latency. High reliability, that is one of the aspects, that is, it should be much more reliable than other systems or other contemporary systems. Massive connectivity, that means the connectivity should be across the globe, not across a region or across a country, but it should have the global connectivity in terms of the mobile and satellite systems are using those. Then edge computing capability. Advanced privacy and security is also one of the aspects. The system should be very much confidential between the hospitals to hospitals, and there should be a relationship of the hospital to hospital relationship in order to exchange the different aspects of the patients and prescriptions and early diagnosis. And then remote surgeries and personalized medicines. So remote surgeries is also one of the aspects in which the healthcare practitioners can guide the patient's surgery. So I'm also going to have a conclusion slide where Sir is asking me to conclude it. So the key components of this healthcare have been examined in the context of green IoT and AI technologies with an eye towards achieving the UN Sustainable Development Goals. a strong AI-based healthcare system using 5G, 6G technology that is suggested using the extendable artificial intelligence system. Thank you very much for listening.
Okay, thank you, Dr. Syed Haidar, for your interesting talk. It seems like what Dr. Asad was saying, it's like a competition between engineer and doctor to get their profession reliable in the future. Okay, we move on to the next keynote speaker. We have here Professor Dr. Abdul Shakur from UIT Peshawar. He will be talking about sustainability in plastic industry, a way forward to meet the environmental challenges and legislative concerns. Okay, I hand over to you, Prof.
Thank you. Thank you, the Shaheed Benazir Bhutto Women University, the Shaheed Benazir Bhutto University of Technology and Skill Development Airport, and Mehran University of Engineering for inviting me this honorable occasion, and I'm also much regarded speaking in front of such distinguished guests, including my former Vice Chancellor Gilani Sahab. So, sir, thank you to speak in front of you. Maybe a little bit tense, let's try. Challenging me at the same time to cover all this sustainability and plastic industry in 10 minutes. Let's try. There are some environmental challenges and some legislative concerns to be tried to let me give you a little bit different level than 5G and 4G and 6G. And let's come to the ground that what we see here. So let me have the little bit intro about me. I am working as a professor in the Department of Mechanical Engineering, UIT Peshawar. I worked as a director there for 3 years, so I have a very good interaction with the industry people, and we have a very good modes of interaction and the collaboration that's with the different industries around the national, international. Being associated with my PhD back in 2013 from Dublin University and the polymer in the field of polymer engineering. I'm also the associate fellow of the Advanced Higher Education UK, and also the fellow of the Pakistani Academy of Engineering. So we have this, we see this materials as the human civilization grows, so there's been interaction with the different type of materials. So the human civilization growth and evolution of this human society and the development of material that goes hand in hand, and there's at each and every stage of this human civilization and the evolution of the society has some sort of interaction with different type of material. And we see that there are iron age and there are, let's say, the metal ages, and we can see the renaissance, and we can see the metal ages, followed by the machine age in the plastic industry, and then we have silicon age, and that's still going on. And this 5G and 6G and artificial intelligence all being possible with this development of the field of material, and to apply this into the real world, that the material has played a very beautiful role in there. And we cannot exclude all the material from whatever the comfort we see around it. If we see from this corner and coming back to the big corner, we still see a different type of material. And we can see multiple things that has been around us. So we have, but this has also put us, the human, into some sort of challenges, because we have enormous production at the global level of the plastics and different type of material. But plastic is one component of the plastic or the material we see around. So there is a huge production, because the human life is more dependent now on these sort of material because of different reasons. Some of them are, and one of the most impactful reason that the human is now most dependent on these sort of material is the economic feasibility and economic situation. And we have seen this global production of the material that for plastic particularly. We have seen around globally around the world, the plastics. And we can see that there is a waste generated along with the production. This one, because the human population is growing, the human is using, and similarly we see the different type of the pollution and different type of the, let's say, the waste, and some of the waste is recycled. But we can see that there is, because this is the total recycling of the waste, there is a gap of this one. There is a significant gap between the production of the material and the reuse of the material at the same time. And this is the challenge for the human, and this is a challenge for us, the technical and engineers and technologists around there, how to face these kind of challenges, how to show this problem. Yes, there are, and as a result of this production as a global, we have seen different type of the, like the pollution, we have seen the normal, the daily life pollution, and we see the different type of calamities around the sea, the flood and all these kind of things we can see. And we can also see some sort of the slogans from the government, from other school of thought, like say, plastics, but this is a viable, this is the justified or just like a wisdom, based on wisdom distribution. In my personal opinion, yes, there can be say no to plastic, but we need to have an alternative. And which is a very difficult job at the same time, because we need to have some sort of the alternative for the human being to make this comfort ongoing. Otherwise, we will be using the same material. So we can see this kind of thing that there is a global issue, because in plastic we produce such huge amount of plastic, so we also see as people very huge and significant use of energy at the same time. This is also, and then we can see the problem of plastic, and then if we are talking about the reuse of material, we still have to use the energy, and this is the double use of material at the same time. So, there is the word sustainability coming into this field, that how we can drive this more ongoing development of material, and how we can bring sustainability to this one, this for the benefit of human society, human life, and we can see a different type of brain words, such as like a keyword, or just like this sustainability, biodegradable materials, biopolymer. But does we see, does we use of these kind of, so why will we work on this one? Because we have worked on this biopolymer, we have worked on this one biodegradable material, how we can use this thing. But does the, what we mean by plastics, like all those materials which are derived from the renewable resources, either the feedstock, the plant-based material, the animal-based, but we have that there are bioplastics that we can use these materials, and we can, but at the same time we also say that there are either some of the school of thought make this confusable, that they are not biodegradable and they turn their material to biodegradable, although they are possible, but there is a significant difference between all these things. And the problem comes in when you categorize a biodegradable material or not a biodegradable material as a biodegradable material for commercial purpose, and challenge the technical people that biodegradable material. And this is how we have to do it. There are different, but do we see that biodegradability is a challenge or is an advantage? Yes, it is an advantage if it is applied in the true sense. But the problem comes in when we talk about, because we have more dependence on the petrochemical based products, the price are doing very well, very high, and all these different types of use of the other resources. So we need a material which has to be not dependent on the petrochemical raw material or otherwise, or we need to have the renewable resources. So the bioplastic or the biopolymer can one of the component or the potential candidate for such kind of the to challenge or to just solve some of the issues that related with the global production of the consumption of the plastic industry. So we have different type of biopolymer, we have different type of biodegradable material, non-combustible, all based on the renewable resources, and some of them are new school of thought is coming in, that is what we call oxy-biodegradable material, which is the traditional petrochemical based material, but the functional group is being changed by changing the chemistry of that one and make that material biodegradable by chemical or different type. But when you make that one, that will not remain as an detect that inherent variability in the system. So there is, we have, but the problem, there are different applications of biopolymer. We can see some of them as an aggregation multi-phenol, mainly for short product life cycle, which are very less short product life cycle. So we can use as like you can say the disposable product, which can be used for short product life cycle and then throw it away. And it can be part of the heat is renewable cycle again if it is biodegradable. It becomes part of the soil or it becomes part of the seed cycle again. So this is then we can see some for the electronic product or the textile industry, we can see some for the automotive industry. But the problem comes in that there is a very technical challenges to mainstreaming these materials into the and integrating these materials into what we see into the main application. Because of their poor mechanical property, because of their poor pickup processing, and particularly the thermal stability of that material. So this is all these research were based on the improvement of the mechanical profile of these kind of material. Because without improving the mechanical profile of these material, we cannot mainstream these material and we cannot integrate this into the material because we have a different type of application. We have to make these materials stronger in replacing the existing material. If it is not replacing the existing material, then the dependency of the petrochemical based material will be continued and still we will be seeing more and more pollution from that. So we have worked on some of these biopolymer with the reinforcement of some sort of the nature fiber, we have get some sort of wood using wood, we have using their thermal analysis that was not so much improvement in the thermal analysis. Mechanically there was improvement in making this material more stiffer. I think in some way it is not wanting to improve this stiffness was making it more stiffer. But somehow we came to use it well. But it's the research, we can use this kind of thing. We can have the viscoelastic behavior of that material that was improved in response to that reinforcement. We also use hemp fiber in making hybrid use it with natural rubbers, and that was further improving the mechanical performance of the material. The viscoelastic behavior was improving. For that material can be used for different types of application. We use the mineral filler as because we have lots of mineral filler available here in our own, particularly this region as well. So we have used talc for just to improve the mechanical profile of these material. And this one, like we can have this different type of mechanical. In this one, we have got very significant improvement on the viscoelastic behavior and mechanical profile and crystallinity of these materials, and that can be used for different type of application. For this one, like other one, we have used some work with the textile, the School of Arts, Textile and Colaba University for the developing this sustainable textile material and making this sustainable design thinking, localism, just using the local resources and integrate the emotional development in that one. That was also focused on that one, and particularly this region because there's lots of deep work is going on in terms of different local resources. It can be used. It can be one of the ways that we can use this one in different type of the just for the business to create business and business opportunity here in this region particularly. This was the bioenergy plan. So we have particularly conclusively we have some challenges with the bioenergy material. These process for mechanical properties and this fiber. We can have a way forward. We have to use the plant biomass in this one. We have to take the genetic and reinforcement. We expand these application structure application. We can describe the application which cannot be recycled, which cannot be biodegradable, like the PLA is considered a material, and then we need to devise a coherent waste management solution. The professors are talked about in the number session about the waste management strategies. We can take benefit from there and different of the more beautiful product. So there is the uptake that we required because we have very much byproduct of our plant-based product like the rice husk, the wheat husk, the other want to direct the business and social economic development. And that will have an expected use of local resources, create job opportunities, bring the innovation and bring the industry languages into to same just into this one. We have done some other project with the School of Safwan University in China to PSF with the development of artificial intelligence for the that is also this project is also going on. We also work with the there's a company in technology in company that develop the building the piping, serious pipe. We will work with some with them and we have developed some master pages with them. So there's also information is also being used in the industry right now. We also work with the KP government in terms of the development IoT. Basically, at this point, I would like to acknowledge all the team because they are my PG students, my MSc students, my university, and once again, I'm thankful for the here, particularly and all the other line and for inviting me and thank you so much.